So today we are going to discuss a very important topic and very important question which was asked by the surveyor in MEO class 2 exam. Okay, and I have tried to put up all the points so you can relate to it, and then this is the expected answer. I'm not here going to explain you the things, but I'm going to tell you give you the rough idea of what you have to explain it to the surveyor point wise. So before we proceed further, I would like to tell you that every day at 8 o'clock in the morning there is a video of maintenance on the machineries of different machineries, whether it is generator and all. So people who are willing to join or getting promoted as third engineer or second assistant engineer, so they can watch those videos related to Yanmar generator, Daihatsu or MAN BMW or main engine even. So overhauling of full decarb video is also there, full and maintenance on turbocharger, maintenance on fuel pump, every all the video, general maintenance of fuel pump, fuel this filters and all, what all routines that we do, how we do take tap it. So please do watch those videos. Those are real videos of machineries working on the machineries, the live video from the company. Okay, so let's proceed. So how flywheel is attached in auxiliary engine? So when we speak about flywheel, you know there is a flywheel in the engine, and you know the function of flywheel and all, why it is there. We are not going to go in depth of that. So it is typically attached to the crankshaft. Okay, so we know that it is attached to the crankshaft. Now it is between the engine and the transmission. Okay, between the engine and the transmission. So transmission is there, means there is an alternator in case of generator, and there is a propeller shaft in case of what you call is known as main engine. So here we are going to discuss about auxiliary engine. Okay, at the end of the crankshaft in other design. Okay, so this is the case. Now it stores power, absorb energy. This is the function of flywheel from power stroke, smooth out engine vibration, mechanical advantage for starting the engine. So there is a mechanical advantage for starting the engine, since when you are giving the air blow, so what is happening is that because of inertia, where when it is running, because of inertia your engine is getting started, because these are compression engine. Now when we speak about crankshaft, now crankshaft flanges has 6 to 8 bolt depending on the design and the manufacturer and the size. So it will have 6 to 8 bolts protruding from it. Okay, now there is a flywheel hub. It has central hub with corresponding number of holes, 6 to 8, that fit onto the crankshaft flange. So that will fit onto the crankshaft flange. Bolts from crankshaft nuts are inserted in flywheel hub and secured with nuts. So the hub that is protruding, so their nuts will go, and then it will try to secure it with nuts. Now when we speak about the tightening, now you saw the design, how it is there, how many numbers of bolts are there. And now when you speak about the tightening, which is very crucial, because engines, you know, it is running at a very high RPM. Okay, these auxiliary engines, because auxiliary engines, they are also known as high speed engine. We have also covered a video wherein comparing the main engine, that is two-stroke engine, and the auxiliary engine, that is four-stroke engine, the difference between two-stroke engine and the four-stroke engine, based on the design, construction and the power output and all those things, you can watch those videos. Now when we speak about tightening, it is tightened in a star pattern. So there is a specific design and pattern for tightening. See, tightening in shipping is very important. Not shipping, in any mechanical machinery is important. Why? Even if you look at the tightening of flange, so when you see it's a flange, and if it has got 4 bolts, so you are tightening in cross pattern. Okay, alternate 1 3 and 2 4. Likewise, even when you are opening the crankcase doors, when you are opening it, so it has got different pattern. Even you see crankcase doors, when you see, there is marking that is given in what pattern you are supposed to tight the door. Okay, otherwise there will be uneven tightening. If you do uneven tightening, there are chances of over tightening, and because of which the bolts will break. And in case if you are not doing it over tightening, there certainly is going to have some more gap on one side and less gap on the other, and because of which there will be leakage from the flanges or any other place wherever you are doing this. So it is tightened in a star pattern. So we are following the star pattern to ensure even pressure and prevent damage to flywheel or crankshaft. So why we are doing it in a star pattern? To prevent damage to flywheel or crankshaft. So this is very significant and important. Locking. Now when we speak about locking, because this is also very important, you see, even in your at your homes you may be having ceiling fan. Now when you try to put the ceiling fan on the roof, after the bolt nut after the nut, there is a hole in the bolt body wherein you put a small wire, okay, small clip, and you enlarge that clip so that in case, because it is, since it is a moving machinery, in case it is running, so the nut is not going to come out from it. Okay, so it is like a safety lock or safety device for it. So the same way all the machineries, those are tightened. Now flywheel is rotating at a very high rpm. So what happens after the nut tightening? You have what is known as uh, there is a there is a securing arrangement for that, which is known as the locking arrangement. So when you speak about Daihatsu engine, often use a locking mechanism such as a lock nut or a cotter pin to secure the flywheel in place. You know what is a cotter pin? People in shipping or in mechanical side, they are familiar with it, no need to explain it. So there is a cotter pin that we place. Now see, this is one method wherein you have a protruding coming out, where you put the nut and then you lock it and then you tight it, first the nut and then you put the locking. This is a simple and common arrangement that is there, but you are supposed to explain all these things. Wherein we have another method also, wherein you have crankshaft, then you have the flywheel, and then you have the intermediate shaft or the tail shaft. All are joined using fitted bolts which does not have nuts, and length of fitted bolts are flange to flange. For fitting we heat the flange and expand for shrink fit, and for removal we do nitrogen cooling, you know. So there is a end to end fitting, there is a shrink fit. Okay, so what we do for fitting it end to end, what we do, we heat it so that it expands. Whenever you try to heat something, there is an expansion that takes place in the metal body. So this expansion takes place, and then you do the shrink fit. And if you there must be an obvious question that when we are supposed to remove it. So for removal, what we are doing is the nitrogen cooling it, so that in cooling it's just the opposite of heating. So in cooling, what is happening is that it will contract, and because of contraction, the size and the diameter, it will reduce. You may not be able to notice it, but that is sufficient because it is in microns that is happening, and that is sufficient for it to come out. So this is there is a note that I would like to read it for you. This is also important. Stuffing of box housing, we have fitted bolts. The shank dia is such that you need to hammer them and then put the nut. So first we have to hammer and then you put the nut. Okay, so these are the different methods of fitting of a flywheel to the engine or the crankshaft. Okay, how flywheel is attached to the engine. So if the question is asked by the surveyor of your oral exam, then you are supposed to tell all these points, that how flywheel is attached to the auxiliary engine. I hope this is clear for you. Thank you so much. Thank you for your valuable time. All the very best for your exams.